Hi folks, we're going to continue with some Chapter 6 homework problems on centripetal force, and here we go. In a particular amusement park ride, passengers are sitting in a cylindrical chamber that spins in a circle. They face the center of the spinning chamber, and at a particular instant the ride has a tangential speed of 3.20 meters per second. A passenger with a mass of 83.0 kilograms feels a force of 560 newtons pushing him towards the center of the circle. What is the radius of the circle? So we have got someone that is in some sort of a ride contraption that is spinning this person around the center of some sort of a crazy wacky amusement park ride, and the force towards the center of a circle, that's going to be the centripetal force acting on my 83 kilogram human being. Well, the equations for centripetal force is mass times centripetal acceleration. Now we have two choices for centripetal acceleration equations. Centripetal acceleration can be v squared over r, or centripetal acceleration can be 4 pi squared r over period squared. So which of these do we use depends on the other variables that we have. In this equation, we are given v, and we're looking for r, so I'm going to be tending towards that version of the equation. So I'm going to insert this in for a, and I'm going to have centripetal force is mass v squared over r, and we are going to solve this algebraically for r. So r, our radius, is going to be mass times velocity squared divided by centripetal force. So let's go ahead and put our numbers in there and see what we get. So the radius of our circle will be our 83 kilogram mass times the instantaneous tangential velocity of 3.20 meters per second quantity squared divided by that centripetal force, 560 newtons. Now I'm going to grab my calculator, and I'm going to say 3.2 squared times 83 divided by 560, and the radius here down to 3 sig figs is 1.52. Now the units should be meters. Let's take a moment and look at where these units ended up and see if they make any sense whatsoever. So I'm going to have kilograms on the top, meters squared, seconds squared, meters squared on the bottom, seconds squared, and all of these is divided by a newton. Now a newton is a kilogram meter per second squared. So let's take a look at that. I've got a kilogram meter squared per second squared divided by a newton, which is a kilogram meter per second squared. So let's see what happens. Kilograms canceled, seconds squared canceled, 1 meter cancels one of those. We do end up with meters. The units work out, and life is good. Let's go on and do another problem. Number 8. What's the maximum speed with which a car can round a turn of radius 77 meters on a flat road if the coefficient of static friction between the tires on the road is 0.88, and give the answer in miles per hour? Now, the basis of this problem is whenever you and I take an exit ramp, there is always a posted speed. And that posted speed is based on a couple things. One, it is both based on the coefficient of friction, and it is based on the radius of the curvature. So here the radius for this particular exit ramp or curve is 77 meters. Now most exit ramps are going to be a banked curve. This one is flat because we have not getting to that point where we have a banked curve involved. So we're going to just simply have a flat curvature here. So let's draw some forces involved. If this is my car, top view of my car, the only force acting on it at this point is the centripetal force keeping it moving in a circle. So that centripetal force is going to be caused by the force of friction. So top view, that's what's going on. Let's take a look at a side view of this car. So here's my car. Here is a back view of it. and here is the back window, little tail lights right here. And what forces do we have on the car? We're going to have a force of gravity down. We're going to have a force normal up, and towards the center of the circle, the centripetal force is going to be the force of friction. So we're going to handle this like we handle all of our force problems. We're going to sum the forces horizontally, and we are going to sum the forces vertically. Now vertically, the car is not rising up or going down, so the sum of the forces vertically is going to be 0 according to Newton's first law. It's a first law situation. And the sum of the forces horizontally is going to be equal to ma. This is an accelerated situation. Why is it an acceleration? Because it's moving in an arc or part of a circle. It's one form of acceleration. But if it's going around part of a circle, it is centripetally accelerated. So now we're going to go forth and create our equations. The friction force is the only force horizontally, so the friction force is going to make my mass centripetally accelerate. Vertically, my normal force up is going to be equal to my force of gravity down. Let's convert these into other things. You know friction force is equal to mu times normal force. That is the equation for friction force. Is mass times centripetal acceleration. Well, one of the equations we have for centripetal acceleration, we know centripetal acceleration is v squared over r. So I am going to put this in for centripetal acceleration. V squared over r. Why did I do that? I have been given the radius, and I want to know how fast, what's the maximum speed that the car can have. So I want to get a speed or a velocity out of this. There is no mass given in this problem. Have no fear, the mass will drop out since we don't have a mass for our vehicle. Our normal force is going to be equal to force of gravity, and you and I both know force of gravity is mass times the acceleration of gravity. Now I'm kind of stymied, so I am going to take mass times acceleration of gravity, and I am going to put that in place of my normal force on that side. So we're just going to keep substituting until we get down to things that we know. Mu, mass acceleration of gravity, is going to be mass velocity squared divided by r. As you can see, mass is on both sides of the equation, so mass will drop out. It doesn't really matter. When we simplify this, mu acceleration of gravity is going to be velocity squared times r, and we want to solve this for how fast can you take that curve. So we're going to solve this for b. We're going to solve this for velocity. So we're going to do a little algebra. The velocity is going to be equal to mu, coefficient of friction, times acceleration of gravity, r, multiply r by both sides to get r up top, so multiply by r. To get v alone, we're then going to have to take the square root of both sides, so the square root of all of that. So the velocity is going to be the square root of mu. Mu, we're told in this situation, is, let's double check, I think it's 0.8, and we are told it's 0.8, and the radius is 77. So let's go down here. Mu is 0.8. 3 sig figs, acceleration of gravity 9.8 meters per second squared, and the radius is 77.0 meters. When I push that through my calculator, what do I get? 77 times 9.8 times 0.8, square root all of that, I get 24.6 meters per second. And the question was, what is that in miles per hour? Well, let's convert. To get rid of meters to go to miles, there's 1609 meters in a mile. And to get rid of seconds, go to hours. There's 3600 seconds in an hour. So we're going to take that divided by 1609 times 3600, and I end up with just about exactly 55 miles per hour. Very, very nice. Let's do one more problem in this video. Let's do number 9. Here's what we have. A small child is swinging a plastic ball on a string in a horizontal circle above her head. So she's got a ball and a string, and she's swinging this in a circle above her head. The ball has a mass of 12.0 grams. The radius of the circle is 10 centimeters. It takes 0.5 seconds for it to go around the circle once. Now, to go around once is the period of rotation, so that is the period of rotation. We want to know what is the centripetal force on the ball. Centripetal force is going to be mass times centripetal acceleration. Now, centripetal acceleration, we have two equations for centripetal acceleration. We can either have centripetal acceleration is v squared over r, or centripetal acceleration is 4 pi squared r over t squared. Which version are we going to use? Depends on the variables we have. This time we have r and we have period t, so I'm going to tend to use that. And I'm going to substitute all of this in for centripetal acceleration. So as my centripetal force will be the mass of the object times 4 pi squared r, the radius, divided by the period square. And before we can put the numbers in there, we have to do one more thing, and that is, when in doubt in physics, go to the MKS units, meters, kilograms, and seconds. So this 3 decimals over, this is going to be 0.012 kilograms. Meters, so this is going to be 0.10 meters. And now we're ready to put our numbers into our equation. I'm going to try and get myself a smidge more writing room. Here goes. So centripetal force is going to be the mass. The mass is, and look, I went down too far. I got to go up a bit. There we go, 0.012 kilograms, 0.0120 kilograms. 4 is constant, pi is a constant. Radius is 0.100 meters. Pi is squared, radius is not. The period is 0.500 seconds, and that period is squared. Let's throw all that in the calculator, and let's see what we get. 0.012 times 4 times pi squared equals times 0.1 divided by, open parentheses, 0.5 squared, close parentheses. I end up with a centripetal force of 0.189 newtons. Now, where do newtons come from? I have got on the top kilogram, then a meter, and then a second that is squared, and a kilogram times a meter divided by a second squared is the definition of 1 Newton. All right, that will do for this time. See you later. Bye-bye.